In eastern Washington state, there is a stretch of country that looks like it was attacked, not weathered, not eroded, attacked by something that came through fast and took the land with it. Geologists call it the channeled scablands, a soil-free region of interconnected dry channels, coulees and cataracts cut into flat-lying basalt, sprawling across something between 1,500 and 2,000 square miles. Scale is wrong, the shape is wrong, the channels are not V-shaped like a river valley or U-shaped like a glacial one. They have a rectangular cross-section, flat plateaus, steep canyon sides, cut straight down into rock. And they behave impossibly. In the words of the geologist who first mapped them, the channels run uphill and downhill. They unite and they divide. They head on the back slopes and cut through the summit. He finished the thought with a sentence you rarely find in a scientific paper. They could not be more erratically and impossibly designed. Scattered across this landscape are boulders the size of small buildings sitting on the surface, made of rock that does not match anything for hundreds of kilometers around. Geologists call them erratics. And there are ripples, ordinary ripples on a stream that are a few centimeters high. These are between about 1 and 15 meters high, regularly spaced, running in long parallel ridges across whole valleys. Those are current ripples, the same thing that forms in sand under flowing water, which means the current that made them was, in every dimension, hundreds of times larger than any river. There are potholes gouged into solid bedrock, carved by underwater vortices called colks, which pluck rock out of a riverbed the way a tornado takes a roof off. And then there is dry falls. It is a cliff 3.5 miles wide with 4 great scalloped alcoves standing 400 feet high above a set of plunge pools. There is no river. To picture it working, you need a waterfall about 5 times the width of Niagara, with something like 10 times the flow of every river on Earth combined, going over it at once. For a long time, none of this had an explanation that anyone found acceptable, and that is the real story here, not the flood, but what happened to the man who worked out what had made it. Before we get to him, one point of fairness. He was not the first to suspect water. Early explorers, soldiers, teachers, and scientists had ascribed the scablands to extensive flows of water from the beginning. In 1882, an expedition under Lieutenant Thomas William Simons of the Army Corps of Engineers named a glacial lake, Lake Lewis. In 1885, T.C. Chamberlain identified Glacial Lake Missoula as a source of floodwater. In 1910, J.T. Pardee published a paper identifying Glacial Lake Missoula. In 1922, Thomas Large reported his own observations on glaciation and possible floods and named a hypothetical Lake Spokane. There were older accounts still. Native American flood stories passed on for millennia may have been inspired by people who watched these events happen. The Kalapuya told of a flood in the story of Panther, Coyote, Whale's Daughter, the flood, and obtaining the fire. And the land itself carries testimony. The Sahaptin name for Rattlesnake Ridge, near Hanford in Washington, is Lalik, which translates as stands above the water. There is no water anywhere near Rattlesnake Ridge today. The man who put it together was called J Harlen Bretz, and even his name was partly his own invention. He was born in 1882 in Saranac, Michigan, the eldest of 5 children of a farmer. The county birth registry recorded him as Harlen J. Bretz. The census listed him as Harlen J. Bretz. When he entered college in 1901, he applied as J. Harlen Bretz, and around the time he finished his doctorate, he dropped the full stop after the J. According to his own children, his given name was actually Harley. His daughter's explanation was that he invented the Harlan thing, just as he had invented the J in front of his name. Most people simply called him Doc. His degree was in biology from Albion College in 1905. He then went to Seattle and taught high school history and physiography, the study of the physical features of the Earth's surface. That is where the geology got hold of him. He began studying the glacial geology of the Puget Sound area on his own account, then went to the University of Chicago and earned a doctorate in geology in 1913. The thing that caught him was a map. In 1910, he saw a newly published topographic map of the Potholes Cataract in eastern Washington and could not make sense of what it showed. 12 years later, in the summer of 1922, he began fieldwork on the Columbia River Plateau. He kept at it for the next 7 years, and between 1922 and 1931 he wrote 15 papers. In 1923 he coined the term channeled scablands for the country near the Grand Coulee, where erosion had cut clean through the basalt. And that same year he published the paper that ended his piece. Its argument was simple. These landforms were made by massive flooding in the distant past, not slow erosion. A flood, sudden, enormous, and brief. He later coined a name for it, the Spokane Flood. He could not explain where the water came from. His numbers required something like 500 cubic miles of it, released at once. He had the effect, in the landscape, and no cause. To understand the reaction, you have to understand what geology believed about itself. The governing principle was uniformitarianism, the idea that the landscape was shaped by processes still acting today, operating slowly over immense time. It was, and is, a superb principle. It had rescued geology from centuries of explaining every landform as the debris of a biblical catastrophe. It taught the 19th century to think in deep time. It was hard won. And Bretz was arriving with the catastrophe. Worse, from the establishment's point of view, a catastrophic flood implied, to anyone looking for it, the possibility of the biblical flood, which the scientific community had spent a century getting away from. There were other reasons for the resistance, and they were less principled. Most of the geology establishment had no familiarity with the remote interior of the Pacific Northwest, and Bretz had little status or reputation in their eyes. In January 1927, the Geological Society of Washington invited the young Bretz to present his published research at a meeting. Several other geologists were scheduled to present competing theories at the same session. Bretz saw it for what it was. He called the group the Six Challenging Elders. Their intention, in his account, was to defeat him in public debate and end the challenge his work posed to their interpretation of geology. And here's the detail that makes this story ache. Sitting in that room was Joseph Pardee, who had worked with Bretz and who had evidence of an ancient glacial lake that would have supported him, the missing water. Pardee said nothing. He worked for the United States Geological Survey and lacked the academic freedom that Bretz, as a university man, had. So, the evidence that could have ended the argument sat quietly in the audience. Bretz defended himself alone and kicked off an acrimonious debate that ran for 40 years. He wrote in 1928, "Ideas without precedent are generally looked upon with disfavor, and men are shocked if their conceptions of an orderly world are challenged." One of his most vocal opponents was Richard Foster Flint, a geologist of considerable standing who continued to oppose the flood interpretation for decades. It is worth pausing to be fair to the opposition, because the caricature is unkind and inaccurate. They were not fools. They were defending a hard-won principle against a claim that, at the time, had no mechanism attached to it. Bretz was asking them to accept a flood of a size nobody had ever measured, from a source nobody could identify, on the evidence of a landscape most of them had never visited. That is a great deal to swallow. What was unfair was the format, not the skepticism, but the ambush, and the fact that the man with the missing piece was in the room and could not afford to speak. The missing piece was a lake, and it was extraordinary. Glacial Lake Missoula existed in western Montana at the end of the last ice age, between about 15,000 and 13,000 years ago. It covered around 3,000 square miles and held roughly 500 cubic miles of water, about half the volume of Lake Michigan, held in the valleys of Montana. It was held there by ice. A tongue of the Cordilleran ice sheet pushed south out of British Columbia and blocked the Clark Fork River, damming western Montana's most important river system. The ice dam typically stood around 610 meters high, 2,000 feet of ice, and flooded the valleys of western Montana some 320 kilometers eastward. It was the largest ice-dammed lake known to have existed. The lake was deep, averaging around 240 meters, with a maximum over 600. Dark and murky was suspended rock flour ground fine by the glaciers. No fish fossils have been found in its deposits. The suspended rock flour may simply have made it uninhabitable. This was not a lake in any friendly sense. It was a reservoir with an ice wall holding it in. You can still see its shorelines. The mountains around the city of Missoula carry horizontal strand lines, old beach levels, cut into their slopes hundreds of meters above the modern town. And then, periodically, the dam failed. When it did, the lake did not drain. It left. Pardee, studying the canyon of the Flathead River, worked out what speed of water would be required to roll the largest boulders the flood had moved. His answer was above 45 miles an hour. He estimated the flow at 9 cubic miles per hour, more than the combined flow of every river in the world. More recent estimates put the largest floods at around 10 times the flow of all current rivers combined. At Camas Prairie in Montana, there are ridges of sediment 25 to 50 feet high and about 300 feet apart. Those are the ripples on the bottom of the lake, formed as it emptied. At Markle Pass, vortices carved culps out of the bedrock as the lake drained. The debris they plucked out lies downstream. This is a landscape where you can still read the direction the water went. Peak flow of the floods is estimated at 27 cubic kilometers per hour, with the maximum flow speed approaching 36 meters per second, 130 kilometers an hour, 80 miles an hour of water. Each flood released up to 19 quintillion joules of potential energy, the equivalent of about 4,500 megatons of high explosive. For comparison, that is roughly 90 times the yield of the most powerful nuclear weapon ever detonated, not once, dozens of times from the same valley over about 2,000 years. The cumulative result was The removal of 210 cubic kilometers of soil, sediment, and basalt from eastern Washington carried downstream and dumped. The floods happened repeatedly. As the ice dam reformed, the lake refilled and the whole cycle ran again, averaging by one estimate about 55 years per cycle. Geologists now believe there were 40 or more separate floods in the last glaciation, occurring over roughly 2,000 years, between about 15 and 13,000 years ago. And they were not the first. Deposits identified in the Hanford Formation indicate that the oldest Missoula-type floods happened before 1.5 million years ago. Because older deposits were largely swept away by later floods, nobody can put a confident number on the ancient ones. Estimates run to hundreds, possibly more than 1,000 cataclysmic floods across the Pleistocene. Working out that there were many floods rather than one took its own fight. The multiple flood case was proposed by Richard Waite in 1980 based on rhythmic deposits called the Touche beds. His most compelling evidence was 2 layers of volcanic ash from Mount St. Helens, found between successive flood deposits, separated by a thin layer of ordinary wind-blown dust. That dust is time. Ash falls in a day. Wind-blown silt takes years to accumulate. 2 ash layers with silt between them means 2 floods with a real interval, not one event laying down rhythmic pulses. Even that is not fully settled. Other researchers argued the sequences do not automatically imply floods separated by decades, and proposed additional water from a vast subglacial reservoir under central British Columbia, which is a genuinely important point about this whole story. Bretz was right that it was catastrophic. The details, how many, from where, how exactly the dam failed, are still being argued about now. Even the failure mechanism is disputed. One account suggests the dam was floated by the lake, letting water escape underneath and disintegrate it. A 2020 review concluded that either overtopping or tunneling, possibly with thermal erosion, caused it to fail. What ended the main argument was not persuasion, it was measurement. Research on open-channel hydraulics in the 1970s put Bretz's flows on solid mathematical ground. And satellite images arrived. Seen from orbit, the scablands stop looking like a puzzle and start looking like exactly what they are, the scour marks of an enormous flow. There is a strange postscript to that. The channeled scablands are now important to planetary scientists as perhaps the best terrestrial analog of the outflow channels on Mars. We learned to recognize catastrophic flood scars on another world by first refusing to recognize them on this one. Bretz kept working, so did Pardee. Over the next 30 years, they collected and published the evidence that identified Lake Missoula as the source of the floods and the maker of the scablands. By the 1950s, his conclusions were being accepted. He wrote on other things too, an extremely influential paper on the origin of limestone caves in 1942, then studies of the caves of Missouri and Illinois. And in 1979, the Geological Society of America awarded him the Penrose Medal, the field's highest honor, for developing one of the great ideas in the earth sciences. He was 96 years old. He had published the original paper 56 years earlier. His remark to his son afterwards has become famous, and it is funnier and sadder than it first appears. All my enemies are dead, so I have no one to gloat over. The philosopher Thomas Kuhn observed that new scientific truths often win, not because opponents change their minds, but because they die off. Bretz's career is the cleanest demonstration of that anyone has. He died in 1981, aged 98. There is a plaque outside the Dry Falls Visitor Center dedicated to him. It reads that he patiently taught us that catastrophic floods may sometimes play a role in nature's unfolding drama. That word sometimes is doing careful work. The lesson of Bretz is not that catastrophism won. It is that both are true, and that a science which allows only one of them will get some landscapes badly wrong. Most of the world is made slowly. Some of it is made in an afternoon. Telling which is which requires looking at the actual rocks, and being willing to be surprised by them. The floods did not only carve, they also built. As the water came out of the Columbia River Gorge, it backed up at a narrows near Kalama, only about 1.5 miles wide. Temporary lakes rose more than 400 feet, flooding the Willamette Valley as far as Eugene, Oregon, and beyond. Icebergs floated in over what is now farmland, carrying boulders, and dropped them where they melted. And when those temporary lakes drained, they left their sediment behind, fine, rich, deep lake-bottom soil, layered across the Willamette and Columbia valleys. That sediment, overlaid by centuries of wind-blown loess, is why those valleys are agriculturally rich, and why the steep south-facing dunes scattered through the Columbia Valley turned out to be ideal for orchards and vineyards. There is something worth sitting with in that. The most violent event this landscape has ever experienced is the reason it grows good fruit. You can still visit almost all of it. Dry Falls has an interpretive center at the top of a cliff that once carried the largest waterfall this planet is known to have had. Upper Grand Coulee is filled today by a reservoir behind a dam, so part of the flood's channel now holds water again, for entirely human reasons. Kama's Prairie has a highway running across its giant ripples, with an information sign. Most people driving it see a slightly lumpy field. That is perhaps the most useful thing about this story. The evidence was never hidden. It was lying on the surface of a landscape people drove through, farmed, and named. A ridge called stands above the water, in a place with no water. Boulders from hundreds of kilometers away. Ripples the height of a house. Channels running over summits. All of it visible. All of it, for decades, explained away. Because there is a particular kind of blindness that comes from having a good theory. Uniformitarianism was right about most of geology. It was so right, so usefully, that it made a landscape screaming about a flood look like a puzzle to be solved some other way. Bretz was not a better scientist than his opponents. He had one advantage. He had walked the ground for 7 summers, and he could not unsee it. So when you look at those channels, running uphill, cutting through summits, dividing and rejoining across 2,000 square miles of stripped rock, you are looking at the work of a few days of water at a time. It happened dozens of times. The last of them was around 14,000 years ago, which means people were living in North America to watch it. Some of them may have told their grandchildren, and those stories may still be being told. And it took a high school teacher from Michigan, a topographic map, 7 summers of walking, and 56 years of being disbelieved to work out what they had seen.